Yeah, so who here has heard and or used of behavior-driven development? Oh, good, so most people. I'm guessing on different platforms, Java, JBehave, SpecFlow, any of those things ring any bells to anyone? Who's heard of those two? The same people, almost. Okay, great. Yes, I've had I actually would like to say that BDD has been around actually longer than Dan North claims it has. He's the guy that coined the term, and I think for me one of the problems with BDD is that it's kind of a big emphasis on given when then and specifications that are specifically written in a specific way. So that's great. I really love given when then. I think it's an excellent way to have acceptance criteria specified. However, I'd like to go into more of what it means to actually see where the whole idea or the need for it came about, and then also to see how in today's software, which is no longer the three-layered cake, everything's not a Rails app or an MVC application in the Microsoft world. How do we do this on things that are faceless, and how do we take advantage of, I'm wearing a Docker shirt, so everyone's into microservices. How does QA fit into that? How does testing, how does specification, all those things. So I gave you some nice example here that you can read, right? Anyway, as I said before, it was officially named and given sort of a Wikipedia entry by Dan North from London area. Great fellow, met him a couple of times to talk about this stuff. So, and a little example that I gave is basically the story. I don't expect you to read this, but you specify stories with certain language, and then you give a couple of scenarios in that given these conditions, when I try to do this, then I expect this kind of outcome. And given that that is expressed in plain English, it gives one of the goals of behavior-driven design is to create an artifact that the whole organization, technical organization, can use. Not just the developers, not just the BAs or product owners, and not just the testers, etc. They all work together on the same specification. I'm a big fan of that. Even without BDD, specs I think should be written before the development starts. It's nice to actually see when you're going to be finished. Traditionally we throw things over the wall. When you're writing some software, you usually get something from the BA. They give it off to some tech leads. They do some estimates. They go away and they code. When they're done, they throw it back over the wall. Very non-agile roots of how we design software, more like bridges. I like to see all of that mesh together and be put where it's responsible to cut down those feedback loops. So everywhere I've worked, I've always pushed for a BDD regiment of having the specs actually written, automated specs if possible, before the developers even start. And that gives you a very clear indication when you're finished. So it eliminates gold plating. It gives you a TDD approach, but TDD that can also apply to your BAs more easily because you're using the ubiquitous language. So Dan North knows Eric Evans really well, who's the father of domain-driven design. And one of the key concepts, in fact, is chapter 1 in his big book. It's ubiquitous language. And that is to determine within the organization a language that you will use to communicate across any kind of technical concerns when you're building the software. So if your business analyst or product owner is talking about a customer, they know that this customer means a specific customer at the end. In some places, a vendor might be your customer. For example, I worked at Pay by Phone. Our customers were really the vendors, such as the City of Vancouver. But the end customer was the person actually paying. So it's really interesting what happens when you don't have ubiquitous language and how much waste is created when you're talking about a customer. To most places, that's simple. But it's really important to have an agreement of what language you're going to use within at least R&D or anyone that's contributing in any way to the software you're making. So some of the mechanics, and this is part of the place where I have a few issues with modern tooling. Typically, it's given in regular English. This is a game example. You can't read it from there probably. I'll make the slides available after if you, on the site if you like. But let's say a game of life type of scenario where you're automating a grid based on your neighbors. You can say, given a 5x5 game, when I toggle the cell at 3, 2, the grid should look like this. When I toggle the cell at 3, 1, the grid should look like this. So, and so forth. Now, this is very easy to read. How does that translate to something that's actually executing code? Well, you have this glue in the middle, and these are usually referred to as fixtures. They take that text and they parse it, paying attention to specific pieces of input. For example, the grid here is a piece of input. In .NET and Java, there's attributes and things like that that mark up a method. And a lot of these fixtures use reflection, et cetera, other things to find methods to be found by whatnot, and take the input here, provide it as actual parameters to the fixture. The fixture itself then does what a regular test would do, such as instantiate the class under test or a system under test. Feed those parameters that you expressed here and take the output after and compare it and get some sort of assertion on it. Anyone not used that before for BDD specifications? Does everyone sort of know how the text gets translated to an actual running test that's going to go against code? Okay, this sort of specification and fixture is very common also on automating the UI. So a lot of times you'll have specifications such as I go to the home page of my website, I click on register, I submit this name, this password, etc., and all this information. When I click submit, I expect that a page will say, you are registered, please wait for an email, right? So that sounds very familiar. So there's two sides of this. A lot of the BDD comes from that high-level acceptance test, right? And we're going to dive into what happens when that, and why that might not be the greatest idea after a while, especially once it gets long in the tooth and you have to maintain this. So BDD before BDD was basically test specification by example. And fitness is one. I'm not sure how many people are old enough here to remember fitness. Yep.
Still around.
Yes, of course it's around. It's great. I'm actually a bigger fan of fitness than I am of some of the BDD frameworks. So it's very easy to parse tables for example data, and so specifications by example were quite simply written with pipes in ASCII, with all the fields fed in there. This is, anyone familiar with fitness? They're pretty familiar with the drill of making ASCII art. And once you parse that in, it goes, obviously, once you feed it in, you have the same kind of fixtures as before. But it really pays attention to the tabular input. So for testing, it's quite great. It's quite good. It's not very verbose to get a whole bunch of different scenarios just specified by all sorts of different permutations of input and output values. This is a simple division specification where you have the numerator, denominator, and then what the quotient's going to be. So that can drive your specification if you're writing a calculator. So this is back in, just to explain who's going to pay attention to this. Again, it is going to be everyone involved in the writing of the software. And we'll see how this actually goes down to a deeper level with microservices and other things. So one of the things about tooling, if you look at SpecFlow and other things, they're quite geeky. I mean, they love to live in things like Visual Studio. And as you start writing your specifications, you get some sort of IntelliSense. Hey, I've had these specifications before. As I start to type them, you get this pop-up that gives you a list, choices of some of the things you might have written before. That's wonderful. However, I find it a little bit too simplistic for what ubiquitous language and a grammar should explain. I'll give an example in a bit with one of my favorites from the previous years that actually did this to a better degree. Has anyone used anything that gives you IntelliSense as you're typing? Yeah, so a few of you. So some of the issues that traditional BDD introduces is that it imitates integration tests. And so a lot of times when you have a whole suite of specifications and someone finds a bug, they're really tempted to say, hey, this bug is important enough so that the BAs and everyone else knows. So I'm going to add it to the spec, that this edge condition I actually want a spec for. That's a very dangerous road because specifications are usually taking a whole system as a whole. And has anyone seen J.B. Rainberger's presentation on why integration tests are a scam? Who's seen that one?
That's awesome.
Exactly. It's a very good presentation. If you haven't seen why integration tests are a scam, please go see that as soon as possible and save your company from imminent death. But yeah, basically what you don't want is an inverted triangle where you have the end-to-end top-level tests. There's a whole reason for that, and it's the multiplying complexities of each component together. So if there's 5 paths through one class, 10 paths through the code in another class, and 7 paths through code in the third class, and they're all involved in the actual workings of the software, to actually, the overall complexity is now a multiplicative of all of those. So you're getting a very, very big hockey stick in terms of how many permutations you're going to have total coverage, to the order of O to the n factorial, which is not good. It's worse than exponential. So the way around that is to obviously minimize that and concentrate on unit tests. There's one caveat for that, however, and most people miss it, is that to actually have complete full coverage with unit tests, both sides of a contract have to be tested. So when you're testing a class and you have some interface, most people mock out that interface or put a stub in or something to test the client thoroughly. They rarely test the opposite side of that same contract. And those this is basically making your mock values and your stub values the values of the tests of the other class from the other side. And usually that half is missing. However, if you do glue those together so that your mocks and your stubs are in sync with the actual testing of those classes and those collaborators, you will then get an additive effect for the complexities. You're going to have an effect of 10 plus 7 plus 5, not times. So you're going to now have constant growth as you're specifying your software. This is why unit tests are much better for catching regressions. So when BDD says, hey, I can communicate this bug really well to the product owners, that's kind of bad, right? Because it gives you that idea that you're going to have just a blanket to catch one thing. You're not going to actually be able to use that test later to pinpoint the exact place it failed. Hey, one of these collaborators failed. I got my feedback. Something failed. I don't know exactly where it is. The other problem with that is when you're testing at the top level, all of these things, behavior-driven design, test-driven design, they're not about checking or testing. They're about design. So when you're looking at a very high level, you're missing the design point. You're allowing all sorts of different things to exist underneath to satisfy that regression. As you move those tests down, you're going to actually improve that specific part of the code, driving the design up. If you don't keep driving the design, because you're testing at a very high level, you're going to continue to get more bugs. And what do you want to do when you get more bugs? You want to specify them again. It's a death spiral. And J.B. Rainsberger goes into a very good explanation of all this. But I thought I'd cover it here because it's something that I think all testers should know. And I don't mean tester as a job title, I mean it as your role, because developers and modern BAs are included in that. So, on to modern BDD. Actually, you know what? I'm going to show you an example of a good framework. I'm just going to skip out of here for a second and see if I can. So I don't use Windows anymore, so I got to spin up a VM. Now, one of the problems with this is that the last time that I saw a proper non-IntelliSense version of specifications was back with Jeremy Miller's framework, who he has always been invited here and has presented, I think, 1 or 2 times at Agile Vancouver. But he certainly is a powerhouse in the BDD world and what he's done for not just ubiquitous language, but more on that idea of grammar, which goes to other concepts in domain-driven design. I don't know if we're going to be able to run this. Let's just see if I can. Bear with me while I make do with our projector here. Might not be able to do this. You know what? I'm going to probably not do this, and if you guys want to come up and see this in action after, come see me up here, and I'll show you what I mean. So let's move on to the modern behavior design, behavior-driven design. So some of the things that are making specifications trickier are the microservices and SOA, and the fact that there's a whole bunch of other messages floating around. You're not really just automating a web UI. A lot of these things are services with faceless interfaces, and they bring into play some interesting concepts that people are now forced to deal with from the architecture world of different types of messages, how to deal with them, and SLAs, etc. So how do we test for this stuff? Well, we go back to domain-driven design. Some of these things are quite useful when you're talking about SOA. And if you haven't seen domain-driven design, it has some important concepts. To me, some of the most important ones are things such as aggregates and repositories. The other thing that testing is missing at the top level, especially when you're doing GUI automation, is you're not paying attention to the state transitions as much. You're always at the at sort of the mercy of what the GUI is showing you. Your database might actually have the right values. There might be a bug in your presentation layer, which is much less, which is not much of a problem, well, not as much of a problem as when you actually have a problem with accepting invalid input. You can always correct your presentation layer, but once you write some things into the database that this customer is now a gold customer and gets 90% off, where there was just a mistake on input, and the problem exhibits itself by having most of your customers get 90% off, you quickly go out of business with things like that. So state transitions are much more dangerous than what is displayed on the interface as the result of one state transition. So events. This to me is sort of the cornerstone of how I've changed my outlook on all of software development, testing, and specification. The traditional, so basically I'm looking at a couple of ways of using events, or event sourcing specifically. So at Pay by Phone, we had a problem where we had a huge legacy code base. Who here works with legacy code from time to time? Right? Who's got a manager class or a common libraries class that they always refer to? Anyone using common libraries? Yeah, same old story. So, but we're agile. We're better than this. We're going to read Michael Feather's book, Dealing with Legacy Code. We're going to put in shims and test parts and change it, and that's going to save us. Well, not really. if you've been around for the last 10 years and attempted to do that with his book and others that are good at it, you can get to some level of sanity in some cases. But in my case, Pay by Phone has a constant battle. They want to have a product, yet all of the customers want their own implementations. So it's always custom made. If you can imagine the parking scenarios in every city, they have all of these things from decades ago. Some, we can't park here when it's a full moon or whatever in one city versus, a regular specification in another. So what happens with that is there's constant churn. And they always look at, oh, well, it's just easier to add another if statement in that giant long procedure to see if this is this vendor, I'm going to now take this extra path here and adjust their parking session because they get half off when it's a full moon. Anyway, so one of the things that events do, and Martin Fowler's definition of event sourcing, is basically taking a system and publishing events from it, so that you can use so they can be used in other systems. Generally, I think the intention with Fowler's definition was to drive things like different status boards of what's going on in the system, maybe drive some more reporting type systems. But used to its full potential, it's actually quite good. You can say that I actually am not going to deal with legacy code. I am going to freeze legacy code. I'm not going to touch it. I'm going to spank anyone that actually touches that code. It's a read-only repository. All I can do is source events from it. And hey, guess what? The only way I can source events from it is put a trigger on the database and send off any updates to the tables. That really freezes what's going on. But it treats the system now as a black box, at least a deterministic black box in some respects, where you can start putting a shell of tests around them. You can extend this functionality by putting compensating actions. So you can do a pre-processor of some request to say that, hey, this is a full moon, but I'm not going to put an if statement in there. I'm going to actually adjust, let's say, the duration by half, but have the actual enforcement be still respecting the full hour, right? Or you can do it in the post, where you can do, hey, someone updated this, and it is a full moon right now, so I'm going to adjust that time to be double or whatnot. But those compensating actions are in brand new classes that have the proper amount of testing, etc. And your external system you depend on is a black box that's deterministic. So moving away from this, you get the full advantage of event sourcing as per Martin Fowler, taken to the next level where it actually helps us quite a bit. The other thing about state transition is what sort of changed for a lot is basically, for a lot of people, is looking at events as the actual value of what the state is. So not even changing the fact that a customer is signed up, has this age, etc. And if you've been to other Agile Vancouver conferences, you probably see me present on CQRS and all that, so I'm going to skim it here. But the key thing is that event sourcing as per Martin Fowler and event sourcing as per Greg Young are very different. Greg Young actually uses events to be the storage of state, meaning it's like opening up your database and looking at transaction logs and seeing exactly what table changed when. But also put those inside each entity, such as customer, such as invoice, etc. All those entities now have borders around them. All they do is read those state changes that were expressed as events. So what does that mean for testing in BDD? It actually means quite a lot. Because a lot of the problems, as I said before, are in the state transitions, where those nasty bugs that just ruin data, and you have a lot of problems with that. It pays to separate your reads from your writes. So that's one of the things that the event sourcing came out of something called CQRS. And basically, you are taking a circular architecture where you're putting in a command model like a Schrodinger's cat. You can never read the state of this. You can only poke it with commands. They either get rejected or they emit an event at the end. That's your rule. That's the only way you can make a state transition. That simplifies what you can do with the system. Over here, in the storage side, once an event is emitted, You can have lots of subscribers to that event. You can even have a total customers count table with one row. And if it sees a customer registered, all it does is does a n+1 on the count. That's all it does. And you can have many of these. Key point is that these things are slaves to the single source of truth. Isn't that nice? We have a single source of truth for all of our data. The other thing about events is that it's totally replayable. So think of a chess game. When someone's playing a chess game on the international stage, all the moves are recorded as to what happened. You can look up online very famous chess games of the last century or more. And you could replay those moves yourself and see what was going on through the guy's head and how many moves was he thinking ahead. Wow, 8 moves ahead. Isn't that the human record? Anyway, maybe it's 12. Anyone know what the chess record is for thinking how many moves ahead? I heard 8. Anyway, so the idea is that your chess board is in a certain state during that game. Everything that each player has done is stored as an event. If we're actually having this as a piece of software, we might have a chess game as a proper abstraction, as a proper aggregate. If I'm going to borrow a term from domain-driven design. So what does that mean for testing? Let's go back to here. I don't have a camera here. I'm not going to use this. I thought there would be a smaller sessions. I was going to write some stuff out, but well, maybe I will. I don't know. What happens when you want to specify something and you want to make the planets align because your database has to be in a specific state, your external services have to be mocked out to a certain state. All those things have to actually play really, really nicely, right? And that's sort of the Achilles heel of traditional acceptance-driven tests and integration tests, that they have to have sort of the whole system working or be tweaked. And so you've probably seen a lot of like setup for a test like that. You get tons of stuff specified, and things are mocked, and they set some weird conditional on that machine so that the database reacts with, you know, a fake database, and then you got to restore your fake database. It's a nightmare, right? So the idea here is that if you're going to test a chess scenario, you can say, given these previous moves, when I try this move, I get an error for illegal move, or it's actually game over, checkmate, whatever it is. That in itself is an event as well. But it gives me a great way to specify everything that I need. And so at PayByPhone, we had this problem of always being at the mercy of every single new vendor saying, well, we have all these rules. Implement them. Tell me that they're going to be done next week. How do you do that quickly? You have your whole giant Oracle database that's, you know, terabytes of info. How are you going to stage all that so you can test it and test it quickly? Well, you have to make a certain transition. So traditionally, you'll have your server calling out to a bunch of services right from the middle of some classes to get the current time, to get the current rate, to get the exchange rate if it's overseas. You're actually at the mercy of quite a lot of stuff, and those have to be mocked out. The better way to do it is to get your server only interpreting commands, as I alluded to before. And what you do when you're testing your client or mocking out your client, all you have to do is populate all those values that you're getting from these other services in plain text and put them into the command. Put subject the server to the command and see if it passes or fails. Now, the nice thing about this is that your setup is easy. Notice we don't have a database or any other service here on this server. All we have is a command, can be rejected or emit other events. So when I'm specifying a parking condition in San Francisco, I can say, given that I parked at 5 p.m. and paid for 2 hours, I'm rejected because there's a loading zone after 6. And I can specify that. Remember that given when then? I can say, given that I'm parking at this location or I can even have specific domain language such as loading zone location. When I attempt to park from this time to this time on this day of the week, I get an error. I'm not allowed, right? So in real practice, what does that mean? Well, when San Francisco gave us our parking rules for the entire city, which didn't match any other city, using this specification, we were able to do pretty much all the systems within 1 day. And that was validating the state transitions, whether people are getting tickets or whether they're parking legally. And that has huge ramifications because that's the bread and butter. If we can't get those right, we're losing money on each one of those. So imagine that. You give the specifications back in a readable format to the guys at San Francisco and they say, yes, that's correct. That's exactly what we want. We're not going to wait for a spike to go through the website for 2-3 months. We'd rather have some feedback. Do we have these rules right? If you're going to give them in a readable format that you can then actually use the same spec to test your own implementation. Now you have no mismatch of keeping anything in sync. Traditionally, it would be a bunch of text that's interpreted by by your company, by your software developers. Go back and forth. They would come back and say, well, you didn't quite get this right. By making sure that your class is deterministic in this way, by being free of third-party influence, and you have all your permutations of values on what the command can contain, and that means things such as time. You know, everyone's gotten into this problem, I'm sure, where you have to mock out your clock, right? Isn't that the worst to test temporal behavior? As you're looking at, oh, now I have to do mock clock, and I have to have my actual clock as a dependency when I instantiate my class. That's ridiculous. I already have enough dependencies. Why do I have to put in the system clock in there? You know, the whole line is going to get quite long as you start putting in everything that you need to be deterministic in a system. Well, with this, you don't have to. When you're instantiating your server class, it's only business rules. You have almost no dependencies on any external services. And that's a huge favor to being able to specify fast and accurately. So, back to design. When we design software, traditionally it might have been some sort of ETL. Hey, you know, data is king. You know, what state we're in is absolutely 100% important. We can't overlook it. So, you know, 15 years ago, we walk into any enterprisey place or a telco, you probably found a DBA or a couple, 3 of them with wallpaper like this around their cubicles, right? And then we got into like, no way, man, UML. We're going to actually specify our design. In fact, we're going to design stuff so that when we draw the little pictures of behavior, it's going to give us code, right? That was fun. And we came into the full swing the other way. Forget about the data. That was horrible. Remember dealing with all the foreign keys? That's a detail. Let the database administrators deal with that. We're going to specify behavior. We're going to say what class is instantiated when, who it calls to, etc. We're going to have sequence diagrams galore, and it's going to be awesome. Well, guess what's getting ignored? So how do we fix this? So we've swung both ways. Where do we come back? Something that was introduced by a guy from Italy based on event sourcing, Greg's work, Martin Fowler's work. It's called event storming. So traditionally, instead of getting together with your DBAs and saying, oh, this table's got to be here, it's got to have this information and that information. Or getting together with your programmers and going like, hey, what's going to happen when I call this method? What's it going to go back to and do that? All of that is geek talk. Both of those methods were totally ignoring the involvement of the business, right? So what's this picture of here? Here we have some programmers, we have some QA people, we have a product owner, probably some other people in there as well. Maybe some infrastructure people or DevOps people, right? And what are they doing? They're specifying all the events of the system. Because guess what? An event is something that happened in the past that contains certain data. That is a fact that happened. It cannot be undone. You have to deal with it. you can talk to the product owner, you can talk to the business folks. If you're not using the same ubiquitous language and understand what data and what events are transpiring within your system, this is not technical language. It means things like customer subscribed. Well, what does that mean? Does it mean that the business guy doesn't care that he specified his name and the programmer does? Of course both of them should care, right? So you're specifying what happened and what information was conveyed during that time. There are lines here. You can't see from there. But this is from domain-driven design. They're context boundaries. So some language, such as customer, obviously, in case of parking, there's two different versions, right? There was the end customer, and then there was the customer that's the vendor, the city. Right? Well, this is where customer might mean one thing here and might mean something else here. When you're talking about enforcement with parking, and you say customer, you're meaning the guy paid for the actual parking transaction. He's the one getting the ticket, not the city. Here, you're talking about the vendor. It's our customer. They're the guys that pay us. They're still a customer. But these lines now give you a context to talk about. So they're called context boundaries. There's other lines in here, and I have other examples of this, what people have been doing over the last year and a half, and they're workflows. So what they would do is draw a line saying, I'm paying for parking. What happens along that line as the transaction is done? What happens when they park to the time that they get a ticket or their session expires and the car has left before that? All of those things are important, and they go to different systems. But you can talk about it with all of these things. So this goes hand in hand with behavior-driven design. It forces you to work with your BAs, your product owners, even your ops guys and DevOps. Because what you can talk about is those lines. Like, wait a second, this writes to this state. There's an event that says that they're a preferred customer at this point. But what if their wife now parks almost at the same time? Wouldn't she expect to get the same discount because they're probably like driving two cars the whole group? You can talk about the SLA now. You can follow those lines and say like, hey, you know, that's got to be important. Why don't we stick a Redis database in there and have some in-memory stuff to look up about people that just got promoted to a gold standard customer or whatever. That way they can have that excellent customer service, right? All of a sudden you're not treating all customers as just generic customers and everyone follows through the same if-then statements in your code. And you can visualize it and you can have this discussion in front. The rule for this kind of thing is no chairs. All the chairs get pushed against all walls facing backwards so you can't sit on them. And you plaster a bunch of paper if you want to draw. A lot of offices have glass or whiteboards all along. So that's where you do that. And that's quite powerful. Because from that, you get those interesting things such as, hey, given these events, what happens? All of a sudden, all your microservices that are looking after certain pieces have those specs, and they're readable. They're readable by business, they're readable by testers, they're readable by developers, and they all go in and work on that one artifact, those specs. So there's nothing lost in translation. Everyone's discussing this. So if you want to have even more ways to collaborate and specify your software, this is a very, very key exercise. And I don't know how many have actually heard of event storming prior to this.
I never heard of it.
It's excellent. I suggest everyone try it, especially if there's a new product that you're going to use, and just see the type of discussions you get. Just see how people have misinterpreted what was said. It's like, what? That event cannot have that information. That person does not know whether they're a prime customer yet or whatever. They don't have that. We never gave them that feedback. So, but then everyone's talking about it. So the BA is not going to look at you funny when you come back with the software, right? So that's about it. I thought I'd leave more time for a discussion about, how to do proper specs for microservices, etc. There's a couple of other things I wanted to cover that I didn't get a chance to find good examples online, such as multi-tenancy and the way legacy systems are kind of manipulated by being forced into Docker containers, etc. But I'll leave that for another time. So any questions? Yes.
At one point you were going over pointing to those charts on the wall and saying there was something from domain-driven design that had to do with defining the customer versus defining the vendor.
Oh yes, sure.
What was that called?
These are called context boundaries.
Context boundary.
Right. So there's things like anti-corruption layers between them that'll translate things such as customer. It's all domain-driven design stuff. So if you look at Eric Evans' book, Domain-Driven Design, those concepts are clearly explained there. And the great thing about the book is that it's, while parts of it are technical, lots of parts aren't technical and are fully utilized in such things as event storming. But I wish I had this back when I was doing the San Francisco stuff. I definitely would have pulled in more people to do this, and less back and forth, even more back and forth would have been eliminated at that point.
So you're going over things that have already happened.
Well, no. So let's talk about that. There's different colors of stickies, as you notice here. The main one is events, because those are the facts that happened. If you're looking at messaging, I introduced messaging a few slides back. One of the core things about messaging is that you get 3 types. If you follow all the patterns, you get a document message, event message, and command message. We didn't cover the document message. A document message is something that's an artifact along a long workflow. So for example, a parking session. Just like a receipt in a restaurant or a diner. When you first order your stuff, your waitress comes up and she writes some stuff down. That same thing goes over to the kitchen. So the stuff gets cooked for you. When it's picked up with that. And when you're ready to pay, you have that same receipt all the way at the end, right? It changes a little bit all along the way, right? They might have to, the kitchen says, hey, we're out of beef, no burger, so you have to go back, adjust it, etc. But that is like your little tally of what happened to you. So documents serve a big sort of purpose in this. Some things I think people use Orange as integrations with external services, but you can make your own standard or convention, just as long as it helps you organize your work. And that way you'll have a nice illustration of what's going on. On that, yes, what happened in the past is important. Events are basically the counterparts to commands all the time, and there's extra events as well. But if you say, I'm going to pay for parking, you get an event, parking was paid for with the appropriate things. It might get populated with more things, such as like what you got charged, etc., and then you go on with that information. But that is a fact now. That has happened. So you can model your whole system around what facts does your system need to support. And this makes it way easier, because notice that you don't need a GUI for any of these things, right? Yet you're talking English, and you're specifying these with automated behavior-driven tests. Given these events, do I get a ticket? Does that answer the question about the terminology of events being in the past? Because they're going to be, a lot of them are going to be used to derive the state, such as this person has parked this multiple times, and perhaps there's a restriction, like in Vancouver, we can't park for more than 2 hours in certain areas, right? Only after a half an hour are you given clearance to park again in that same spot. So this temporal sort of notion of when you're allowed to do that. So the spec would be, given that I parked from 9 to 11, and I attempt to park at 11:15, I invoke the test of that business rule that you have not yet spent half an hour away from the parking spot. And you can continue with those things. So the fact that you can talk about facts in your test is very powerful, because it drives on those state transitions and how everything else is subservient to your state transitions. So when you turn the on-off switch in your system, all you have left is what you stored, and those are the events of what has happened. Yes?
Hi. So you had a slide with 2 pyramids, one upside down
Yep.
and one side up. And I thought that was a great insight, that you really want to make sure that your unit tests cover everything, but you can't make sure that your GUI tests or your end-to-end tests cover everything. How do you know when you're done with your GUI tests? Like unit tests, you have code coverage, say like, okay, you want 90% code coverage, great.
Yeah, I mean, even code coverage is a huge lie because it just tells you, what line items what line numbers in your code you hit. It doesn't do anything for your permutations of values. So it's a huge problem. That's why dealing with the verification of the actual values and combinations of the mocked values on the other side of the contract is very, very important. The other thing about that I wanted to mention is the only tool that you have where you have post and preconditions check at compile time is given with code contracts in .NET and Microsoft. When you compile with Visual Studio and you enable contracts, it's the sort of first big feat of having deterministically checked values, possible values at compile time, which is huge. That will give you 100% coverage. So a lot of the unit tests, like null cases, if is this null, all that kind of garbage, all those unit tests go away if you're using something that will give you all possibilities based on the implementation. So simple declarations above the methods that are specified, such as this parameter cannot be null, right? And post conditions as well. The compiler will interpret that and actually give you a compile time error that I can't guarantee that this is not going to be null. So right away that gets rid of that unit test. And that's great. The moment you can ease the burden of maintaining your tests, that's a great thing to have. So I don't know, there may be others on the market now that are coming out, but as far as I know, Microsoft's code contracts were the only place where you could find compile time checking for permutations.
I was more talking about how do you know when you have enough GUI tests?
How do you know whether you have enough GUI tests?
Yeah, how do you know, how do you define code coverage, or how do you know when you...
I wouldn't worry about code coverage with your GUI tests. I would use them as, is this communicating enough to the product owners and everyone else to know what the software was intended to do? So there's testing and there's checking. There's a whole bunch of stuff with tests that come into play. And there's a difference there of what the purpose of those things is. Unit tests are there as a safety net to check everything. Tests are there on the higher level to specify the software. They don't need 100% code coverage. At least in how I do it. Yes.
You talked about working with San Francisco, and you said that you managed to interpret all their business rules in one day.
Yeah.
That kind of sounded slightly miraculous to me. Could you talk a little bit more about that?
Yeah, I basically concentrated on the state transitions and the reporting of whether something has, so events could also be used also on the other side. If I go back to here, here's how you may attempt a parking session and what kind of, how much money you're charged, etc. On this side, there's the enforcement system that might be, subscribing to those events. So you can test the enforcement system the same way. You can feed in a whole bunch of events that have happened, and you want to test whether you get a ticket or not. Well, that was very easy to do. Because you essentially look at everything that they specified, and you say, okay, well, let me think of all the different events that could have happened that would lead to me being able to deal with the situation. And immediately those events explode with the proper abstractions you need in your software, which gives you that design part, right, of BDD. So that's essentially how it was done. So I never updated any UI for it. Any of those things. I wasn't sitting there making sure that the San Francisco logo was exactly this many pixels so they're happy. That's not important. What's important is that we charge the right customer the right amount of money, or we have no business. Right? Everything else is subservient to that very important thing. So go ahead.
So for each business rule, you basically try to think of the boundaries and go, well, if this rule is true, then I need to test this state, this state, and this state.
Yes. Yeah. You can have many different read models here, all subscribing to the same events, or have some subset of events that are common with them. There may be, some crazy rule. We also did private lots where, if the lot gets full to 90%, they go ahead and still put up full anyway, because there's probably people still that haven't bothered to park that are going to, and they have to have that 90% cutoff. So that's another read model, right? So that specification is on whether that sign full is on or not for the guy in the ticket booth at that parking lot. So you can definitely use that same event thing to not just test this, but also to test how each piece of information, without actually doing the GUI, although you could. But it also frees you from having to deal with a database, frees you from having to deal with all these sequence diagrams and whatnot. I think are we good for a time, or we have a little bit more? I think we got
A little
15
bit
minutes. Okay, yes.
So you talked about, you talk about events and things that have already happened. So if it's an application and you haven't even started yet, that means you just talk about what's happening now, like what are people doing that's not automated yet, they're parking or whatever. Is that
Well, if you're specifying software, just like you did before with the ETL diagrams and et cetera, you're sort of planning on like, how am I going to store all this data, right? So you're always planning what's going to happen in the future anyway. You're just kind of saying to yourself, like, if I had this system working, what kind of facts do I want to be stored somewhere in it, right? How do I want to use these facts then later? So that's probably the biggest takeaway. Marrying the behavior with the data is the key, and you can solidify those with factual statements that you can then use those facts to test different scenarios.
Would
Yes?
you not also put in actions with that? So you know, it states something, the action, the data, and yeah.
Well, you would have commands for certain things, right? So that's how most of the specifications were done, was given these events. When I try and park, or park is a command, right? And it specifies the stall number, how many minutes, etc., right? What time it's at. And biggest, obviously the thing that really hit us in the face in that system is it's such a time-sensitive system, right? And abstracting time and testing against time where you're mocking out clocks is horrible if you're not doing this. If you've tried it before, having a dependency clock object in every single class you have is rubbish. It's a horrible way to work.
Can you elaborate a little bit more on that? So how did...
Yeah.
Sure. So if you have a class that has certain things that require the clock to be at certain parts of what it's doing, you inject an object called, not a real clock, fake clock. First time I'm called, I'll give you this time. Second time, this time. Third time, this time. You get into all sorts of weird scenarios like that. And then what if the implementation changes? Someone else is refactoring something and they add another call. Like, oh man, that means my mock is out of sync now. I have to add that extra thing. Now imagine you keep going like this. It becomes an unbearable mess because time is abused so many times. It's got log entries everywhere. Just imagine all the places you're hitting time. So you go, oh well, don't worry about calling the mock time on this one. This is just a logging thing. So just call the real clock here. I'm like, oh, but I already passed the reference in, right? And so you go back and redesign, and it just ends up being, in my experience anyway, it's always been a problem when trying to mock time.
So when you use commands now, is that the main thing that solves your problem? I'm just curious a little bit
Yep.
more how that...
So essentially, where you would have had these commands, these lookups to, let's say time is one of them,
Yeah.
you'd have this being called maybe 5 times. You have to mock that up to make sure that things are expiring, etc. What you're doing here beforehand is, you're in a temporal thing, you're probably going to have this as multiple command requests. But essentially means you feed in the time that you're feeding the command, and that's it. You may have some things on the other side, on the client, to say, hey, this took whatever amount of time. But anyway, the big thing about this is that it starts to drive your design better. Now you see that, hey, maybe I shouldn't be mixing this all in one method. Maybe I need to have this as a workflow because I'm testing for a 5-second delay. Maybe that's a workflow thing where we're talking about those documents that the previous action happened at this time versus the other time.
effectively, you're setting a scenario that you're then going to test in the command set, right?
Yeah.
You're saying it is this time, these are the conditions. That
Yes,
exist.
exactly.
Boom, go ahead.
Yeah,
Because then it doesn't really matter when you send the next thing.
that's right.
Real temporal doesn't carry anymore.
That's right. So you're trying to get rid of the reliance on the clock. Wherever you can do that, it's going to make your software better.
Any variables, you're removing variables.
That's right.
By forcing commitment
Yeah.
to this variable is true.
Yep, and other things like exchange rate could be another one for whatever. You feed that in, and this thing becomes a whole lot more testable, very deterministic. You have less infrastructure to support for getting the scenarios set up, for sure.
I'm guessing it also makes the tests just easier to read.
Yes, absolutely. Because the tests, if you don't do this, would end up with a whole lot more setup for in my experience anyway. Especially even at the unit test level, when you're developing the application, aligning the planets is a little bit tricky. Whereas in this case, you're specifying a deterministic amount of inputs, and then you're just doing. So you're getting pure functions essentially if you're a composite. You're getting things that will, given the same input, you'll always have that output. That's a huge, awesome guarantee to have in your software. Anything else? Okay, well that, oh, sorry, one more.
No, I'm just real curious about it. I mean, it sounds great, and I want to learn more about event storming.
Uh-huh.
But I also, I've just recently read Jeff Patton's story mapping book and experimented with story mapping over the years.
Mhm.
And I found real success with that. I think in some ways it's the same because you're walking along the timeline that those are events in a way.
Mhm.
We're talking about how different users will use the system.
Yep.
But sometimes I think maybe the key, no matter what you call it or how you do it, is getting all these people in the room
That's
together,
right.
talking and drawing on a whiteboard or writing sticky notes. That's really the key, whatever
That's right.
specific process you use, event storming or story mapping.
Yep, that's correct. So yeah, the question is, why isn't this just like story mapping, right? It sort of is, the event storming. The key thing is that getting a whole bunch of people together in one room to discuss this stuff and actually have that interaction is not easy. People are away on conferences, they have business meetings, your product owner, or BA, whatever. Maybe it's that you're releasing some software and a few of the devs and QA people are not available. It's like, you really got to make the times that you can get enough people from representing everyone together is at a sort of a hard combination to come by, right? You're always going to have someone missing. So when you do get a good representation of your company, might as well have the largest amount of things you can gain from that, right? Get the most design, get the most artifacts. So basically getting those facts of the system is huge. The story stuff is, to me, a little too superficial because it doesn't dive into the implementations, it doesn't dive into the ubiquitous language at the core, underneath system. What's going on? When is a parking session expired? Things like that. Why does it involve that data? Why does that happen then, right? Why is that an event? Why do we even care about that? These sort of things start to come up. And so you walk away with way more artifacts that specify and help your design, get your abstractions right, and even get to the DevOps side where you're looking at SLAs properly. And that's done without a specific story on there, but it's implied, and you can start looking at that. It's like, hey, what happens when these events are within 2 minutes of one another? You can have those discussions. But yes, they absolutely are, at the surface level, if you look at this, they start with the same conversations. What happens when this customer does this? Let's see what happens. But let's just go a little bit deeper in a responsible way where we're not getting to technical jargon and say, like, what are the facts of the system?
We got any more questions? No, I guess we're a little ahead of ourselves.
No, that's great. That's good. I don't think we could really dive into event storming much more unless we actually participated in a mock exercise, which I think would be good for a workshop.
I was going to say.
Exactly.
Your workshops are coming on.
Yeah.
And that's the sort of thing that makes it really great work.
Yeah, exactly. Yeah. So hopefully we'll have one at some point for event sourcing
All right, I'm gonna hold
or
you to
event
that.
storming. Yeah, sure. It'd be fun.
Okay, folks, they're scheduled to bring lunch in about 10 minutes, about 1:45. So if you want to mingle and chat or go out and enjoy the
Oh,
fresh air for 10 minutes.
I still have the BDD framework to show if anyone. I just didn't display well on the projector, so anyone that's curious can come
Yeah.
around and take a look at the
So you got
example.
Time to do that. then.
Yeah, exactly. So we have some time for that.
Okay, thank you.
And feel free to enjoy the sun today. We have the whole patio area. Access.
Doing the GUI, although you could. But it also frees you from having to deal with a database, frees you from having to deal with all these sequence diagrams and whatnot. I think are we good for a time, or we have a little bit more? I think we got
A little
15
bit
minutes. Okay, yes.
So you talk about, you talk about events and things that have already happened. So if it's an application and you haven't even started yet, that means you just talk about what's happening now, like what are people doing that's not automated yet, they're parking or whatever. Is that-
Well, if you're specifying software, just like you did before with the ETL diagrams and et cetera, you're sort of planning on like, how am I going to store all this data, right? So you're always planning what's going to happen in the future anyway. You're just kind of saying to yourself, like, if I had this system working, what kind of facts do I want to be stored somewhere in it, right? How do I want to use these facts then later? So that's probably the biggest takeaway. Marrying the behavior with the data is the key, and you can solidify those with factual statements that you can then use those facts to test different scenarios.
Would
Yes?
you not also put in actions with that, so you know, it states something, the action, the data, and the, yeah.
Well, you would have commands for certain things, right? So that's how most of the specifications were done, was given these events when I try and park, or park is a command, right? And it specifies the stall number, how many minutes, etc., right? What time it's at. And biggest, obviously the thing that really hit us in the face in that system is it's such a time-sensitive system, right? And abstracting time and testing against time where you're mocking out clocks is horrible if you're not doing this. If you've tried it before, having a dependency clock object in every single class you have is rubbish. It's a horrible way to work.
Can you elaborate a little bit more on that? So how did?
Yeah.
Sure. So if you have a class that has certain things that require the clock to be at certain parts of what it's doing, you inject an object called, not a real clock, fake clock. First time I'm called, I'll give you this time. Second time, this time. Third time, this time. You get into all sorts of weird scenarios like that. And then what if the implementation changes? Someone else is refactoring something and they add another call. Like, oh man, that means my mock is out of sync now. I have to add that extra thing. Now imagine you keep going like this. It becomes an unbearable mess because time is abused so many times. It's got log entries everywhere. Just imagine all the places you're hitting time. So, oh well, don't worry about calling the mock time on this one. This is just a logging thing. So just call the real clock here. I'm like, oh, but I already passed the reference in, right? And so you go back and redesign, and it just ends up being, in my experience anyway, it's always been a problem when trying to mock time.
So when you use commands now, is that the main thing that solves your problem? I'm just curious a little bit
Yep.
more how that.
So
makes that
essentially, where you would have had these commands, these lookups to, let's say time is one of them,
Yeah.
you'd have this being called maybe 5 times. You have to mock that up to make sure that things are expiring, etc. What you're doing here beforehand is, you're in a temporal thing. You're probably going to have this as multiple command requests, but essentially means you feed in the time that you're feeding the command, and that's it. You may have some things on the other side on the client to say, hey, this took whatever amount of time. But anyway, the big thing about this is that it starts to drive your design better. Now you see that hey, maybe I shouldn't be mixing this all in one method. Maybe I need to have this as a workflow because I'm testing for, a 5-second delay. Maybe that's a workflow thing where we're talking about those documents that the previous action happened at this time versus the other time.
Effectively, you're setting a scenario that you're then going to test in the command set, right?
Yeah.
You're saying it is this time, these are the conditions. Of
Yes, exactly.
So we go ahead.
Yeah,
Because then it doesn't really matter when you send the next thing.
that's right.
Real temporal doesn't carry anymore.
That's right. So you're trying to get rid of the reliance on the clock. Wherever you can do that, it's going to make your software better.
Any variables, you're removing variables.
That's right.
By forcing commitment
Yeah.
to this variable is true.
Yep, and other things like exchange rate could be another one for whatever. You feed that in, and this thing becomes a whole lot more testable, very deterministic. You have less infrastructure to support for getting the scenarios set up, for sure.
I'm guessing it also makes the tests just easier to read.
Yes, absolutely. Because the tests, if you don't do this, would end up with a whole lot more setup for in my experience anyway. Especially even at the unit test level, when you're developing the application, aligning the planets is a little bit tricky. Whereas in this case, you're specifying a deterministic amount of inputs, and then you're just doing. So you're getting pure functions essentially. If you're a composite, you're getting things that will, given the same input, you'll always have that output. That's a huge, awesome guarantee to have in your software. Anything else? Okay, well oh, sorry, one more.
No, I'm just real curious about it. I mean, it sounds great, and I want to learn more about event storming.
Uh-huh.
But I also, I've just recently read Jeff Patton's story mapping book and experimented with story mapping over the years,
Mhm.
and I found real success with that. I think in some ways it's the same because you're walking along the timeline that those are events in a way.
Mhm.
You're talking about how different users will use the system.
Yep.
But sometimes I think maybe the key, no matter what you call it or how you do it, is getting all these people in the room
That's
together,
right.
talking and drawing on a whiteboard or writing sticky notes. That's really the key, whatever
That's right.
specific process you use, event storing or story mapping.
Yep, that's correct. So yeah, the question is, why isn't this just like story mapping, right? It sort of is, the event story. The key thing is that getting a whole bunch of people together in one room to discuss this stuff and actually have that interaction is not easy. People are away on conferences, they have business meetings, your product owner, or BA, whatever. Maybe it's that you're releasing some software and a few of the devs and QA people are not available. It's like, you really got to make the times that you can get enough people from representing everyone together is at a sort of a hard combination to come by, right? You're always going to have someone missing. So when you do get a good representation of your company, might as well have the largest amount of things you can gain from that, right? Get the most design, get the most artifacts. So basically getting those facts of the system is huge. The story stuff is, to me, a little too superficial because it doesn't dive into the implementations, it doesn't dive into the ubiquitous language at the core, underneath system. What's going on? When is a parking session expired? Things like that. Why does it involve that data? Why does that happen then, right? Why is that an event? Why do we even care about that? These sort of things start to come up. And so you walk away with way more artifacts that specify and help your design, get your abstractions right, and even get to the DevOps side where you're looking at SLAs properly. And that's done without a specific story on there, but it's implied, and you can start looking at that. It's like, hey, what happens when these events are within 2 minutes of one another? You can have those discussions. But yes, they absolutely are, at the surface level, if you look at this, they start with the same conversations. What happens when this customer does this? Let's see what happens. But let's just go a little bit deeper in a responsible way where we're not getting the technical jargon and say, like, what are the facts of the system?
We got any more questions? No, I guess we're a little ahead of ourselves.
No, that's great. That's good. I don't think we could really dive into event storming much more unless we actually participated in a mock exercise, which I think would be good for a
I
workshop.
was gonna say.
Exactly.
Start coming on.
Yeah.
And that's the sort of thing that makes it really great.
Yeah, exactly. Yeah. So hopefully we'll have one at some point for event sourcing
All right, I'm gonna hold
or
you to
event
that.
storming. Yeah. Sure. It'd be fun.
Okay, folks, they're scheduled to bring lunch in about 10 minutes, about 1:45. So if you want to mingle and chat or go out and enjoy the
Oh,
fresh air for 10 minutes.
I still have the BDD framework to show if anyone. I just didn't display well on the projector, so anyone that's curious can come
Yeah.
around and take a look at the
So we got
example.
Time to do that.
Yeah, exactly. So we have some time for that.
Okay,